Are you ready to attempt some more mole problems? I know they might seem intimidating at first, but I promise, once you get the hang of the problem-solving procedures, you will have no issues solving all sorts of mole-type problems. In the last video, we dealt with mole conversions for solids. During this video, we will look at conversions involving liquids. Let's review the mole facts we know so far. To convert between grams and moles, use the atomic mass or molar mass of the substance. Use Avogadro's number, 6.02 times 10 to the 23rd, to convert from moles to atoms or molecules. I will introduce a new conversion factor here in a bit, but let's start off by looking at a problem. In Nebraska, ethanol can be extracted from corn and used as a fuel additive to help reduce our dependence on fossil fuels. If you have 2,360 milliliters of ethanol, how many moles would you have? Start this problem the same way. Place the value given in the problem in the first section of the train track. I'm going to extend my track a bit because this conversion will require a couple of steps. Looking at the mole facts we have so far, you can see neither of them are much help to start off. We do not have a conversion that helps us switch between milliliters and moles. In fact, we don't even have a mole fact with milliliters in it. Do not dismay. Looky right here. The problem gives us the density of ethanol in grams per milliliter. Density is simply another conversion factor we can use in our problems, specifically when we are working with liquids. In this case, there are 0.85 grams of ethanol in 1 milliliter of ethanol. This conversion factor can be written two ways: 0.85 grams per 1 milliliter, or 1 milliliter is 0.85 grams. We were given 2,360 milliliters to start, so we can use the density to convert from milliliters to grams. Then, to solve the problem, we can use the molar mass of ethanol to convert from grams to moles. Milliliters need to cancel, so I'm going to place 1 milliliter on the bottom of the train track, which means 0.85 grams of ethanol goes in the top section. Doing this causes the milliliters of ethanol to cancel. We are supposed to find moles of ethanol. If we stopped here, we would only calculate the grams of ethanol. So now we have to use the molar mass to convert from grams to moles. 46 grams of ethanol is equal to 1 mole of ethanol. Grams have to cancel, so 46.0 grams of CH3CH2OH will go in the bottom section of the train track, meaning 1 mole of ethanol goes in the top portion. This causes grams of ethanol to cancel, leaving us with moles of ethanol. Fantastic. To perform the calculation, multiply the numbers on the top of the train track together and then divide by the numbers on the bottom of the train track. In this case, we need to multiply 2,360 times 0.85, then divide by 46. This will give us 43.6086 moles of CH3CH2OH. The number given to us in the problem has 3 significant figures, so the answer can only have 3 sig figs. The correct answer to this problem is 43.6 moles of ethanol. Before we look at the next problem, I want to point something out. When you are doing these problems, I will give you conversion factors. For example, in this problem involving ethanol, you were given the density and the molar mass. If a conversion factor is given, you should count on using it to solve the problem. This is very important. If a conversion is given to you, use it. If you are not given a conversion, don't use it. All right. Let's look at a problem that will require us to use all 3 conversion factors that we know so far. Reading this problem, we need 2.57 times 10 to the 24th molecules of toluene, and the question asks us how many milliliters of toluene would this be? We are given the density of toluene and the molar mass of toluene. Keep in mind what I just explained. If you are given a conversion factor, you will use it. Let's think about how to approach this long conversion. We are starting with molecules, And the only conversion factor we have that includes molecules is using Avogadro's number to convert from molecules to moles. Okay, if we use Avogadro's number to convert to moles, then we can use the molar mass to convert from moles to grams. The molar mass is given to us, so we know we have to use it. From here, we can use the density of toluene to convert from grams to milliliters. Once again, if we were given the density, we know we have to use it. So we have a three-step conversion here to convert from molecules of toluene to milliliters of toluene. Start with 2.57 times 10 to the 24th molecules of toluene in the train track. Then make a really long track to prepare for this three-step conversion. Now convert molecules to moles. There are 6.02 times 10 to the 23rd molecules of toluene in a mole of toluene. Molecules need to cancel, so 6.02 times 10 to the 23rd molecules will go on the bottom, which means 1 mole of toluene goes in the top of the train track. Doing this causes the molecules of toluene to cancel. If we stopped right here, we would only calculate the moles of toluene. We need milliliters. So now we have to keep going. There is no conversion factor that converts between moles and milliliters. So we will first have to use the molar mass to convert from moles to grams. 1 mole of toluene is equal to 92.0 grams of toluene. Moles must cancel. So 1 mole of toluene will go in the bottom section of the train track, and 92.0 grams of toluene will go in the top section. This causes moles of toluene to cancel, leaving us with grams of toluene. We are supposed to find milliliters of toluene, not grams, so we must perform one more step. We were given the density in the problem, and we still haven't used it. Now is the time. Use the density to convert from grams to milliliters. This conversion could be written two ways: 0.8669 grams of toluene per 1 milliliter of toluene, or 1 milliliter of toluene per 0.8669 grams of toluene. Grams have to cancel. So 0.8669 grams of toluene will go in the bottom section of the train track, leaving 1 milliliter of toluene to go in the top portion. This causes grams of toluene to cancel, leaving us with milliliters of toluene. Whew! Finally. To perform this calculation, multiply the numbers on the top of the train track together and divide by the numbers on the bottom of the train track. In this case, we need to multiply 2.57 times 10 to the 24th times 92, then divide by 6.02 times 10 to the 23rd, and divide by 0.8669. This will give us 4.5306 times 10 to the second milliliters of toluene. The number given to us in the problem has 3 significant figures, so the answer can only have 3 sig figs. The correct answer to this problem is 453 milliliters of toluene. Now, take a look at this problem. We are given 125 milliliters of lavender oil and are asked to calculate the molecules of lavender oil. The problem gives us the density and molar mass of lavender oil, so we know we have to use those. You may notice that this problem is the exact opposite of the last problem. In the last problem, we were given molecules of toluene and asked to find milliliters of toluene. In this problem, we are given milliliters of lavender oil and are asked to calculate molecules of lavender oil. This means we have another 3-step conversion on our hands. Let's get started. Place 125 milliliters of lavender oil in your train track and then make a nice long one. Here's what we are going to do. We will use the density to convert from milliliters to grams, then use the molar mass to convert from grams to moles, and then finally use Avogadro's number to convert from moles to molecules. The density of lavender oil is 0.875 grams per milliliter. Milliliters need to cancel, so 1 milliliter will go on the bottom of the train track, which means 0.875 grams of lavender oil goes in the top. Doing this causes the milliliters of lavender oil to cancel. If we stopped right here, we would only calculate the grams of lavender oil. We need molecules. So let's keep going. There's no conversion factor that converts between grams and molecules. So we will first have to use the molar mass to convert from grams to moles. 930 grams of lavender oil is equal to 1 mole of lavender oil. Grams must cancel. So 930.0 grams of lavender oil will go in the bottom portion of the train track, and 1 mole of lavender oil will go in the top section. This causes grams of lavender oil to cancel, leaving us with moles of lavender oil. We are supposed to calculate molecules of lavender oil, not the moles. So we are close, just one more step. We must use Avogadro's number to convert from moles to molecules. Moles have to cancel, so 1 mole of lavender oil will go in the bottom section, meaning 6.02 times 10 to the 23rd molecules of lavender oil goes in the top section of the train track. This causes moles of lavender oil to cancel, leaving us with molecules of lavender oil. My goodness, look at how awesome we are. To perform this calculation, multiply the numbers on the top of the train track together and divide by the numbers on the bottom of the train track. In this case, we need to multiply 125 times 0.875 times 6.02 times 10 to the 23rd, and then divide by 930. This will give us 7.0799 times 10 to the 22nd molecules of lavender oil. The number given to us in the problem has 3 significant figures, so the answer can only have 3 sig figs. The correct answer to this problem is 7.08 times 10 to the 22nd molecules of lavender oil. Okay, we have solved mole-type problems involving solids. We just solved mole-type problems involving liquids. In the next video, I will introduce you to one final mole fact that allows us to perform mole-type problems involving gases. Stay tuned.